So our Frog FRQ, we had a frog who was given a goal distance and a maximum number of hops to reach that goal distance. And we were asked to build two different methods. We were asked to build simulate and run simulations. So let's go ahead and build those methods. Where's my the other side of my computer? Weird. So first, we're going to build that simulate method. So we know what type it is. We were given that information. So public Boolean simulate. There's no parameters. Now, what methods are present in our frog simulation class that we can work with? I'll jump back over to that other screen real quick. So variables and methods that we have access to are that goal distance method, that goal distance variable, that max hops variable, and that hop distance method. So all three of those are defined within this class, and those are the exact variable names and method names that we need to use. Those are the ones that have been declared. We have to use those. So I'll write those over on the right side. We have our goal distance. We have our max hops. And we have our hop distance. Okay, so all right, please move this window. Thank you. Okay, so those are our three things that we have to work with. So our simulate method, we are tasked with simulating this experience. We have max number of hops. We have a distance we're trying to reach, and hop distance will tell us how far the frog hops each time. So if we have a specific number of times we're going to hop, what's the best way to accomplish hopping that number of times? So if I know my maximum number of hops, how can I simulate doing that number of hops?
A for loop.
Use a for loop. So we're going to use a for int I equals 0, I less than max hops. And that variable name has to match exactly because that's the one we were given. I plus plus. What do we want to do inside of this loop? So we want to, for each value of I, we want to hop, right? How do we simulate a hop? What method do we have access to simulate a hop? We have hop distance. So we're going to call hop distance. What are we going to do with that value that we get back?
Save it into goal distance.
Say that again. I didn't hear what you said. I'm sorry. So, okay, what does hop distance give us? Oh, yeah, it's in the chat. It does seem like your audio broke. I'm sorry. So what does hop distance give us?
The distance of the hop.
The distance of one hop. So how are we going to use this goal distance? So we want to add together all the distances that we get and see if we've reached that goal distance. So what are we going to add hop distance to?
What I did was I made like an int variable inside.
Make a new variable. All right, where are we going to make this variable? Above the for loop, inside the for loop? Above the for loop. All right, and let's just call this one distance. And we're going to start at position 0. Now, this variable, this distance variable, can be named whatever you want because we weren't provided this variable. This is a local variable for this method that we're writing. We can name it whatever we choose. So we've got our distance, and then in our for loop, we want to say distance plus equals that hop distance. Let's move this over a little bit. Oh, wow, that is not what I wanted at all. Please let me select those parentheses. No? Okay, just, there we go. Hop distance plus equals, or no, distance plus equals hop distance. Then what do we want to do with our distance? What are the ways that we can exit our loop or exit our whole method?
If the distance was greater than the goal distance.
So if our distance is greater than the goal distance,
Right.
then I think we can just return our value, right? If we've passed the goal distance, we're good. We can return true. So if distance is greater than or equal to our goal distance, then we return true. Is there another way that we can exit our for loop early?
Wait, wasn't one of the instructions like if the distance was negative?
Yeah, if we go back past the beginning, the frog is just going to give up. Doesn't matter how many jumps it has left. If it's gone past 0, it says, all right, I'm done. I can't make it. So that check, if our distance is less than 0, we can jump back to the very beginning, jump back to equaling 0. But if we pass 0, we give up. So if distance is less than 0, return false. All right, is there anything else that needs to go inside of our loop? So we've got our updating our distance. We are checking if we've reached the goal or if we've gone past the beginning. Is there anything else that needs to happen in the loop? No, that all seems good. Is there anything else, excuse me, that needs to happen inside the method?
We return false if like not.
We need to return false if we exit the loop because we didn't make it to the goal and we didn't go negative, which means we made the max number of hops, but we didn't make it to the goal. So we then say return false after our loop is over because we know we did the max number of hops, but we didn't reach the goal. I have a question in chat. Can we use an else if inside of our loop here instead? Absolutely.
That doesn't change it.
It doesn't change it whatsoever. That would work exactly the same. That's totally fine. So this code that I have here is just one possible answer. As long as your code hits all the boxes, it checks all the boxes, it matches all the things, you're totally fine. So there's our simulate method that we wrote. Now let's, real quick, let's look at the rubric for this question, part A. Now you won't have access to this on the actual exam. This is for the graders reading your code, checking whether they give you these points. But you can kind of infer what the points are going to be based on the question. So our intent for part A is to simulate the distance traveled by a hopping frog. So did we call hop distance and use that distance to update our position? We did. Did we initialize and accumulate the frog's position at most max hops times using a loop? Also yes. Did we determine if the distance represented by those multiple hops is at least our goal distance? Also yes. Did we check if we go negative? Yep. And did we return true or false in the correct locations? We totally did. So we earn all of those points. Boom. We would get max marks on that FRQ for that thing we just wrote. And these are generally a little vague. We can have it implemented in different ways. I could have used a while loop. I could have used all kinds of different things. I could have implemented this slightly differently, and I could still earn these points. Now, something to be aware of is during the AP exam, if you don't understand how to fully implement a question, still give it a shot, because you can earn partial credit. You can earn 3 of the 5 points here, but not all 5 of them. If you are confident that you know how to do at least part of it, do that part of it, and you'll probably earn at least a couple points on that FRQ question. Now, it's much easier to do this on the written one than the digital one, because I think on the digital one, you're not allowed to go between questions. So once you've answered a question, either multiple choice or FRQ, you can't go back to previous ones. But on the written one, you can absolutely move between questions. And on both tests, you will have access to that Java quick reference, that document that I showed you on the first day of our review, where it outlines a whole bunch of different methods we can use. So our other method that we were asked to write was the run simulations method. Run simulations gets a number of times it wants to simulate, and it's going to call that simulate method that number of times, and it's going to keep track of how many times it was true, how many times we got or we successfully made it to the goal, and then we'll return the proportion of numbers, so of times that it was successful. So if we ran 400 times and we got 100 trues, we would say 100 over 400, which gives us 0.25. So let's go back to our whiteboard. Let's make a new page. So we are going to write our run simulations method now. So this is a public starts with P, public double run simulations, and we get an int num as a parameter. So similarly to the previous question, we have a number of times that we want to loop, that we want to do something. So let's do a for loop and use that variable num for int I equals 0, I less than num, I plus plus. And what do we want to do inside of this run simulations method, inside of that loop?
What was this method supposed to do?
So this method is supposed to call our simulate method num number of times and return how many times out of the total, what proportion we got true back. Now, something else to keep in mind is on this method, assume that our simulate method works as specified, whether or not you fully implemented it in part A. So if you're not confident in how you wrote it in part A, assume that you got it right, assume that it works correctly, and then write this method as though it worked correctly. So your score for part B is not dependent on your score for part A. They're completely distinct from each other. All right, so we want to loop num number of times, and we want to simulate that many times, right? So we want to call our simulate method. Now, what do we want to do with our simulate method? We want to check if it's true or false. So what are we going to do with that value? We need to make a decision, right?
Yeah.
How do we make decisions? With an if. So we're going to use an if. And since this returns true or false, we can have it just be our entire condition for our if statement. If simulate returns true, what do we want to do?
Add one to like a variable it creates.
Add one to a variable. So what type should this variable be? All right, int. Int, let's call it successful, or just success. We'll start that at 0. And if simulate was true, we can say success plus plus. We can add 1 to our success variable. And then at the end, after our loop, this is all we need to do in the loop. We just need to call simulate, and if it was true, add 1 to our success. We don't need to keep track of how many failures there were, because we have the total, we have the successes, and we can kind of figure out failures at that point. Not that it's super relevant, because all we care about is the proportion of success over total. So our whole method is going to return that value. So we're going to return success over num. Now, is that all we need to do? If I have n num equals 400 and success equals 100, what's 100 over 400? It's 1/4 or 0.25. But in Java, if both of these values are integers, 1/4 is actually just equal to 0 because it's going to truncate that decimal place. And so if we look here, both success and num are int values. So there's two ways that we could fix this. We can either do a typecast to double down here. We can typecast success as a double so that one of our two operands in this division is a double, then it will return a double value. Or alternatively, we could define, that's not what I wanted to do, what at all? We could define success as a double instead of as an int. And then once again, we have success, which is a double, divided by num, which is an int. Double over int will give us a double value. So either of these scenarios would give us that correct division. But we need to make sure that both of these values are doubles, otherwise we're not going to get our correct division. Make sense? All right. So let's look at the rubric for that question. Part B, yes. Are we calling the simulate method the specified number of times? Yeah, we're using a for loop. There we go. Are we initializing and accumulating a count of the true results? Also, yes. Are we calculating the proportion of successful simulations using double arithmetic rather than integer arithmetic? Yep. And are we returning that calculated value? Yep. So we actually accomplished both of those on the same line. That's fine. But yeah, our code meets all four of those requirements. We're totally good. So that is the whole Frog FRQ. That is both of those questions. Did that implementation make sense? All right. Today, our topic is classes. So what things do we need to build a class? What things are required for the construction of a class? I'm going to define a new class file. What things do I need inside of it?
Yes, signature. Or,
So we need the class header, absolutely.
oh, class. You know this private or public, right?
So the class should always be public. So it'll be, yeah, public class and then whatever you name it. So that's all part of the header. what other things do we need inside of the class? We need the body. So what things go in the body?
You would need instance variables.
Instance variables. So let's say instance variables first. Go ahead. We need instance variables. We need constructor or constructors if we're going to overload. And last, we need methods. So let's kind of construct a class together. What kind of class should we build together? In a previous class, I did triangle. Another class, I did shoe. So what do we want to build?
Pizza.
Say it again.
Pizza.
Could you send it in chat? Because it's coming through real garbled. Pizza.
Pizza. Yeah.
Great idea. So let's do a pizza class. So anytime we write a class, we're going to define it as public so that it's accessible from other classes. So public class pizza. Now remember, anytime you write a class, that first letter should always be capitalized. Unlike a regular variable, we want the first letter should be capitalized. Regular variables, first letter should not be capitalized. So what are some instance variables we might need in this class? Toppings. What kind of variable should we do for toppings? Do we only want one string for toppings? What if I want multiple toppings?
I guess it's just number of toppings.
So we could do a number of toppings, but what if I want to have just a collection of all of the toppings on my pizza? What could we use for that? We could use an array of strings. So let's say we have a string array. Actually, square toppings. And then let's do size or radius. And that's just going to be an int. All right, so what should our constructor look like? Actually, I missed something here. What did I miss on my instance variables? My goodness.
The private thing.
We missed our access specifier, which for instance variables should always be private. So we want our private and private. So we've got our two private instance variables. Let's look at a constructor. So what is the access specifier for a constructor?
Public.
Public. So public pizza, because a constructor has the same name as the class. And let's say we get our two parameters, string array t and int r. And that should be a comma, not a semicolon. And then inside of our constructor, we say toppings equals t, radius equals r. So we've got our constructor that takes multiple parameters. Let's even make a default constructor. So public pizza. If I'm making a default constructor, I need no parameters to be passed. So let's say our toppings list is just cheese. Our default pizza is just a cheese pizza, so that's the only topping. And our radius, let's give that the radius of 10. I don't know. That seems like a decent size for a pizza. So our default constructor, we get no parameters, but we still need to initialize all of our instance variables. So we're going to give them a default value. All right, and then let's say we want to calculate the price. How might we calculate the price of a pizza? This is going to be a method. So methods should always be public. What kind of value are we going to return out of this method? Double, sure. Double, and then let's say calc price. And let's just say that the price is a function of the size and how many toppings there are. So let's say number of inches times the number of topping, or number of inches times 2 plus the number of toppings. Say it's $1 per topping. Sure, just I don't know how pizzas are priced. I've never worked at a pizzeria, so we're just gonna make something up. So we're gonna return a value. We're gonna return our radius times, let's say 2.5. 2.5 times our radius plus the length of our toppings. So toppings dot length. And there we go. We are calculating some kind of a value based on our instance variables. We return how much this pizza costs. So that is how we can build a class. So let's take a quick look at our next set of questions for today. Let me share my screen. So again, on AP Classroom, you should be able to see this day 2 review assignment. I've included a few multiple choice questions this time so that you'll have access to these. We'll go over these during our next class together. I'm not going to really introduce those. I'm going to let you just take a gander. And yeah. So let's introduce our FRQ for today, the code word checker. So a code word checker object can be constructed with 3 parameters, being 2 integers and a string. The first 2 parameters specify the minimum and maximum code word lengths, respectively, and the third parameter specifies a string that must not occur in the code word. A code word checker object can also be constructed with a single parameter that specifies a string that must not occur in the code word. In this case, the minimum and maximum lengths will default to 6 and 20, respectively. So if we look at these 2 little examples, we've got our code word checker SC1 equals new code word checker. 5 is our minimum, 8 is our maximum, and $sign is this character that we're not allowed to include. So this string is happy. Oh, okay. In here. So this string is valid. We're actually going to also write this is valid method. So is valid on happy will give us true because we have 1, 2, 3, 4, 5 characters that meets the minimum. So that 5 and 8, that is inclusive. So we've met the minimum, we've not exceeded the maximum, and we don't include a $sign. This is a valid code word. Happy $sign, still within the bounds, but it includes that prohibited character, that prohibited string. So we're going to return false from is valid. Is valid of code is less than our size, so it's too short. Happy code is too many characters, 1, 2, 3, 4, 5, 6, 7, 8, 9 characters long. That is larger than our maximum and also therefore invalid. So we'd return false in that scenario as well. Our other example is when we call our constructor with just the one parameter, in which case the small size bound is 6, the upper size bound is 20. So if my prohibited word is pass, my pass is actually valid because this P is capital and this P is lowercase. So it does care about type, or not type, about upper or lowercase. So we only care if lowercase pass is present. So my pass is 1, 2, 3, 4, 5, 6 characters long, so that meets the minimum, and it does not include our prohibited word, so this word is valid. My passport, on the other hand, still a valid length, greater than 6, less than or equal to 20, but it includes that substring pass, which means it's invalid, not allowed. We have a test for happy. We have 1, 2, 3, 4, 5 characters, and that is shorter than 6. Therefore, not allowed. We can't have that one. And we have is valid on 100,000, million, billion, trillion, quadrillion, 1 quadrillion, which has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 characters, which is too many. It is longer than our 20 character limit. So this code word is too long, even though it doesn't include, so we get false, even though it doesn't include that prohibited word. So our assignment here is to build the entire CodeWordChecker class. So the whole thing, including any instance variables, any constructors, and any methods that are necessary to fulfill what you see in this question prompt. Now remember, something that we have access to, both while we're doing these questions, and you'll have access to it the whole time you're doing the exam, both during your multiple choice and free response, is this Java quick reference. So if there's something that you're not super sure how to do, maybe check on the quick reference and see if there is something on here that might help you accomplish that goal. So you can accomplish, I think, all of these FRQ questions using only things that are on this quick reference. So if there's a method that's not here, you don't need to use it. There's other ways that you could accomplish it, absolutely. But you can absolutely accomplish this FRQ with just the things present on this quick reference.
Are all FRQs capable of answering with?
I believe so, yes. So that is our time for today. Any questions on any of what we talked about before I let us work for 5 minutes? Alrighty.